Okay, so before we start today, just a couple of things. First of all, I should be back on Friday, so you've got today and tomorrow to work on this new 9.4 section, which is on the GCF factoring. Um, we'll probably spend that Friday working on this as well. We'll just end up being a day behind everybody else. That is okay. Um, Nothing we can do about that. We'll just have to make that work. So scores for the quiz you took last Friday are posted in Infinite Campus, hopefully. If there's some of you that might want to retake that, let me know and we can set up a time to do that. Probably would be next week then, because we want to work on that stuff before we did that. So hopefully you should have this packet. It looks like this versus 9.4 Introduction to Factoring today. If you don't have that, make sure you get it before we move on. Before we start here, one thing on this. There is a typo going on here. And if you look at it, you probably can figure this one out pretty easily. The axis of symmetry is supposed to be x equals 1. And the vertex is listed as 2, -3. Well, that's not going to work. The vertex is going to be at 1, -4. And then I believe everything else is correct. So go ahead and graph the parabola that has those 4 things going on. Pause the video while you're doing that and then come back and I will go through that one with you. Okay, so here we go. The axis of symmetry at x equals 1. We've got our dashed line there. Our vertex, we're going to have that at 1, -4. So it is on, switch colors. So it is on the axis of symmetry. So over 1, down 4. There's our vertex. Our y-intercept at 0, -3. So that is right there. We can also plot a point symmetric to that, which would be a good idea. Since this is the axis of symmetry, we know it goes through that point as well. And then we've got our x-intercepts at -1, 0, and 3, 0. Then we can go ahead and graph our parabola right like that. Now, they want us to go ahead and confirm some things that we've done based on the graph. And they say that is the equation that we have. And so this is all review from what was on that quiz last week. So here you've got x squared with nothing in front of it. Remember, that means it's 1x squared. B is going to be this -2 in front of the x. And then C is going to be this -3 at the end. Because the A term is positive, we know that it goes up. You can see, of course, it does go up. Our axis of symmetry is the equation -b over 2a. So we've got -2 over 2 times 1. Well, -2 is just +2, and 2 times 1 is 2, and then 2 divided by 2 is 1. So the axis of symmetry is 1, which matches what we had. To find the vertex, we plug that back in for x. So 1 squared is, well, 1 times 1 is 1. Minus 2 times 1, well, 2 times 1 is 2, so -2, and then -3. Well, 1 minus 2 is -1. Take that -3 and you get -4. So 1 comma -4, that matches what we changed it to, which is good. And then the y-intercept is just the c value, so 0, -3. Because if we plug in 0 for everything, those terms go away. Multiplying by 0 gets rid of that stuff. Now, the big thing here that we are going to talk about today is, well, what about the x-intercepts? Do we have any way to confirm that those, in fact, are the x-intercepts of this graph? At this point, we don't have any way of doing that with algebra. We could look at them on the graph. We could plot something like that on Desmos and click on them and see where they are. We don't have any way to do that ourselves. And so that's really what we're going to be talking about today and where we're going with this last unit here. So, first thing we've got to review is something from way back at the beginning of the year. This was very, very beginning of first try, which is GCF. GCF, if you remember, means greatest common factor. Somewhere around the room, you should have some factor charts that have been printed out and laminated. If you can find those, that would be great. It would help you out a lot. I'm going to go ahead and list out factors of these numbers. But we're looking for the biggest number that goes into both of those numbers. That is the greatest common factor. So if I'm looking at these 10 and 20, I'm going to start by listing the factors of 10. Well, factors of 10 are like 1 times 10, 2 times 5. Those are my factors of 10. My factors of 20 would be 1 times 20, 2 times 10, and 4 times 5. Then I just look through and I find, well, what's the biggest one that's in both? Well, 10 is the biggest one that's in both. So 10 is the GCF of those two numbers. Could do exactly the same thing with 8 and 12. Could list out the factors of 8. 1 times 8, 2 times 4. And then I can list out the factors of 12. 1 times 12, 2 times 6, 3 times 4. And then I'm just looking for the biggest one that goes into both, and it is 4. So go ahead and try 4 and 6 on your own here, and then pause the video. Come back in about 30 seconds, and I'll go over that one. Okay, so we're looking at the factors of 4. We've got 1 times 4, or 2 times 2. So 1, 4, and 2 are the factors of 4. The factors of 6 would be 1 times 6, and then 2 times 3. If you have the factor charts out, these are listed on there. So all you really have to do is go through and find the biggest one, which in this case happens to be 2. So 2 is the greatest common factor of those two numbers. It is the biggest thing that goes into both of them. Now, if you look down below, this is new. Greatest common factors and variables. When we see things like x and x squared next to the fifth, how do we find the greatest common factor of two things like that? The best part about that, they are even easier. So if I'm looking at these, remember x, well, x is just x, but x squared would be x times x. That's what it is factored out, written as a product of two things. Well, what's the biggest thing that you see in both? Well, I see an x in this one, and I see an x in this one. So x is the greatest common factor of x and x squared. That's it. That's all we got to do with that one. If I'm looking over here, x to the third would be like x times x times x, and x squared would be x times x. Well, in both of them, there is at least 2 x's. This one happens to have 3, but they both have at least 2, which means the greatest common factor here is x times x, which we would just write as x squared. And then if I get something like this, you might think, well, those numbers are getting bigger. This is going to be harder. But let's look here. X to the third is just x times x times x. X to the fifth would be 5 x's all multiplied together. And the big thing we're looking at here is, well, this one has 3 x's. This one also has 3 x's plus some more. So the thing that's in common between them is those 3 x's, or x to the third. That's our greatest common factor. So when you have variables with the same base, the GCF is the variable, or I'm not going to say variable, I'm going to say the expression with the smaller exponent. So when you've got x squared and x, we just pick the smaller one, x. X to the third, x to the fifth, we pick the smaller one, x to the third. If you've got x to the 17th and x to the 53rd, well, the greatest common factor of those two is x to the 17th. You don't have to do anything. You can tell just by looking at them, which is great. Now, when we start to put these together, we're just going to have to do the numbers and then the variables separately. And then they're all multiplied together, so that's great. So when I look here, I'm first going to start out with the 10 and the 20. I'm just going to kind of circle 10 and 20. This is where I look at my factor chart. And we already did this one, but 10 is 1 times 10 and 2 times 5. 20 is 1 times 20, 2 times 10, 4 times 5. And so 10 is my greatest common factor. So the greatest common factor of these expressions has a 10 in it. Then I look at my variables. I've got x squared and x. Well, x is going to be my greatest common factor. It's the lower exponent. There is an x in x squared, but there's only one x here. So 10x is going to be my greatest common factor. So finding the greatest common factor of the numbers is still the hardest part of this. And we've done that already. So here we've got 8 and 12. And again, we did this already, but 8 is 1 times 8, or 2 times 4. 12 is 1 times 12, 2 times 6, or 3 times 4. And so 4 is the greatest common factor. Then I can look at the x to the third and the x. Well, x to the third and x, the lowest exponent there is the x. So I just keep that one. 4x is my greatest common factor. Finally, on this one, between the 4 and the 6, the greatest common factor is 2. We did that one just up above. And between the x squared and the x to the 5th, x squared is the greatest common factor because it's the lower exponent. So that is my GCF of those two expressions. So here we go. Oh wait, one more thing here. Leading coefficients. When you noticed when we've written linear functions and exponential functions, we've talked about these two forms, and these are in what we typically refer to as usually standard form, although with linear functions it's a little weird. But the really important thing is that they go in order of exponents from biggest to smallest. So with linear, we've got x to the first there, and even though it's not written, that's really x to the 0 there. And then here we've got x to the second, x to the first, and x to the 0, even though it's not written. And so they go in order from the biggest exponent to the next, all the way to the lowest. And so the leading coefficient is just the coefficient, the number multiplied by coefficient of the largest exponent. The largest exponent term. So in both of these cases, the m here would be the leading coefficient, the a would be the leading coefficient. So when we're looking at these, assuming that they are already in order from biggest exponent to smallest, which this one is, goes exponent of 1, no variable at all. 4 is leading coefficient. Here we've got 4x squared plus 4x, so they are in order, that's good. So 4 is leading coefficient. Here they go in order again, so x and then no x. So this negative sign, remember, is -1. That's our leading coefficient. And then on this one, again, they're in order. X squared, x, and then no x's. So -2 is our leading coefficient. We'll come back to that a lot more later on. That leading coefficient is going to be pretty important. Okay, flipping to the back. Factoring. This is what we're going to be spending pretty much the rest of the year on. Factoring is writing a number or expression as a product. Remember, product means multiplication. And so what I was doing at the beginning when I was, just a second ago, when I was taking 20 and rewriting it as 4 times 5, that's factoring. I'm just taking that and splitting it up into two things that are multiplied together, and they're equal to the original. Now, most of the time, what we're going to be doing is factoring in such a way that we're basically going in the reverse direction of the distributive property. It still actually is the distributive property. We're just going backwards from the way we've been doing it before. And the way we're going to be doing that is actually thinking a lot about that distributive property. And this GCF thing comes into play. So the first thing we always want to do is when we're factoring with GCF method is find the GCF. So I'm looking through and I'm saying, okay, look at the numbers first. I've got 2 and a 4. You've got your factor charts. What's the biggest factor that goes into 2 and into 4? Well, it's 2. So I'll write down the 2. Then I look at my variables. I've got an x squared and I've got an x. Well, what's the biggest thing that's in both of those? Well, that's the x. So 2x is my greatest common factor. Now here, I want you to be thinking about distributing. And we're playing the game of like, what would I need to multiply by? So in other words, what would I have to multiply the 2x by in order to get 2x squared? Well, I've already got the 2, so I don't need another coefficient here. I really just need the 1. I can write the 1. Usually you wouldn't write the 1. But I need to multiply this x by something to get x squared. Well, x times x is x squared. So if I put just x or 1x there, 2x times 1x is 2x squared. Then I can go to my second one here. 2x times what makes positive 4x? Well, I have 2, and I need to multiply by something to get 4. Well, 2 times 2 is 4. I already have an x, and I only need an x, so I don't need another x here. What I do need is a plus sign, right? If this is going to be a positive number, because it's not the first number, it's got to have the plus sign. I don't write the plus sign there usually because it's the first number, but it's really there. Same thing where I really probably shouldn't be writing the 1. I should really just have x plus 2 written there. Now, the best part about factoring by GCF is if you can do the distributive property, which all of you can. This is one of the best quizzes we did all year. We can always check our work. So I can go through now and say, okay, well, let's distribute this. And if I get back what I started, I did it right. So what is 2x times x? Well, that's 2, because 2 times 1 is 2. And then x times x is x squared. Then, well, what's 2x times 2? Well, 2 times 2 is 4, positive 4, and times x. Did I get back what I started with? Yes, so I know I did it right. Okay, next up, at this one, I'm going to start with my numbers. I've got 3, I've got 6. Looking at your factor chart, what's the biggest thing that goes into both 3 and 6? Well, it is 3. Now, one thing you might notice here is this one has an x term, but this one doesn't have an x term. So there is no variable in common between the two of those. So I don't have a variable in my GCF. That's fine. Now what I want to look at is, well, what do I have to multiply by? 3 times what would make 3x squared? Well, I've already got the 3. I just need to multiply it by the x squared. And then I can go back and say, okay, well, 3 times what would make negative 6? Well, I need to take a positive times a negative to get a negative, and 3 times 2 makes 6. So I know it has to be minus 2. And again, you can distribute that back and check. 3 times x squared is 3x squared. 3 times negative 2 is negative 6. We did. Okay, next one up. Here's an example of one where we don't have any numbers as part of the GCF. In front here is just 1. In front here is 8, or negative 8. The biggest thing that I could pull out, or the biggest common factor there, would just be 1. And I'm going to write it there for now. But remember, we don't usually write the 1 if it's the leading coefficient. We don't do that. Then I can go back and look. Well, I've got x squared and x. Well, the lower of those exponents is the 1, just the x by itself. So I know the greatest common factor is just x. And then I'm going to ask myself, okay, well, 1x, or really just x, times what makes x squared? Well, x times x makes x squared. And then x times what makes negative 8x? Well, I've already got the x. I just need the negative 8. X times negative 8 makes negative 8x. And there we go. Final one, this is going to be what most of these tend to look a lot more like. We've got 10x squared minus 15x. So we'll start with the numbers. What's the biggest thing that goes into 10 and 15? If you look through your factor charts, 10 has 1 times 10, 2 times 5. 15 would be 1 times 15, or 3 times 5. And so the biggest number there is 5. Then I can go through and look at my x's. I've got x squared and x to the first. Well, the lower one is just the x by itself, the x to the first. And then I'll ask myself those questions. 5x times what makes 10x squared? Well, 5 times 2 makes 10, and x times x makes x squared. Go into the next one. 5 times what makes a negative 15? Well, I need to make it negative, and 5 times 3 is negative 15. I already have the x, so I don't need another x. And there's our factored form. 5x times 2x minus 3. Feel free to pause, go back, look at those again if you need to. The next part of this is really not any more difficult. It's just adding one extra term. Okay, so now we've got trinomials. And these are not really any bit harder than the binomial ones. You just have to look at all 3 terms when you're doing these. So we'll start off the same way. We're going to find the GCF this time of all 3 of these terms. Start with just the numbers. I've got 2, I've got 4, I've got 6. Look at the factor lists of all of those. 2 is 2 times 1. 4 is 4 times 1, or 2 times 2. 6 is 6 times 1, or 2 times 3. What's the biggest number you see in all 3 of those? It is the 2. So 2 is our greatest common factor there. Then you go ahead and look at all of the variables. Not just the ones that have variables, all of the variables. This one's got an x squared. This one's got an x to the first. This one doesn't have any x's at all. The most they have in common is nothing. They don't have any x's in common because that last one doesn't have any x's at all. It's just the 2 that's in common between all 3 of those. That is a really, really common mistake that people want to make on these. They go, okay, x squared x. They ignore that little 6 and they say, okay, there's an x in there. I pull out the x. No, that 6 does not have an x in it. That x would not be in common if you pulled it out. It's not the greatest common factor. So now we can go through and look at what do we got to multiply. 2 times what makes 2x squared? Well, I've already got the 2. 2 times 1 would make 2. I don't really need to put the 1 there. But I do need to get that x squared. So 2 times x squared makes 2x squared. Now I got to ask the question, 2 times what makes positive 4x? Well, I need 2 times 2, 2 times a positive 2 to make the 4. And then I need an x. So 2 times 2x would make 4x. And then the same thing with the 6. 2 times what makes 6? Well, positive 3. Make sure you're putting signs in there even though they're positive. This is one expression. We cannot leave those plus signs out, or we have now 3 separate expressions that don't have anything to do with each other. Okay, let's look at this next one. First, start out with your numbers. We've got 3, negative 3, and 3. Well, the biggest thing that goes into 3, 3, and 3 is 3. Great. Now we can go back and look at our exponents, our variables. Well, I've got x squared, x to the third, x squared, and x. This time we do have a variable in all of them, and the lowest degree or lowest exponent one is just the x by itself. So 3x is our greatest common factor. Now we can go through and multiply. 3x times what makes 3x to the third? Well, I've already got the 3. I don't need to multiply by anything to get 3, or just 1, but I'm not going to write that. But this x, I need to multiply by something to get x to the third. Well, x times x squared makes x to the third. So I need to put an x squared here. Next one down, 3x times what makes negative 3x squared? Well, this time I've got a positive and I need to make it negative, so I need to multiply by a negative something. It's already 3, so really what I'm multiplying by is negative 1, but I don't write the negative 1 in there. Then I've got to say, well, x times what makes x squared? Well, it's x times x makes x squared, so I've got negative x. And then the last one, 3x times what makes 3x? Well, it's already 3x. This time I do have to put the 1, because if I don't put the 1, there's nothing there at all, and that wouldn't be good. So 3x times x squared minus x plus 1. Final one here. Here we go. So we're going to start out with our numbers, 5, 10, and negative 15. Look through those factor lists. List them out if you need to. 5 is 1 times 5. 10 is 1 times 5, or 1 times 10, or 2 times 5. And then 15 is 1 times 15, or 3 times 5. You can see there is a 5 in all of them. So there's a 5 in our greatest common factor. Then you look at the variables. X to the third, x squared, and x. Well, there's at least one x in all of those. X to the first power. So I'll put that there. Then I can go and play the what do I multiply by game. So 5x times what makes 5x to the third? Well, I've already got the 5, but x times what makes x to the third? Well, that's x squared, because the rule is add the exponents. Next one down. 5 times what makes 10? Well, 5 times 2 makes 10. And x times what makes x squared? X times x makes x squared. And the last one, this is when we got to worry about that negative sign. 5 times what makes negative 15? Well, that's negative 3. And then the x times what makes x? Well, I don't need another x. It's just the minus 3. And so there we go. That's our factored form. Remember, we can distribute these back out, and we'll end up right back where we started. That's the important thing. Okay, final thing here is with the negative leading coefficient. Whenever you have that negative coefficient, negative leading coefficient, you always want to factor out a negative as your GCF. Get my pen to connect again. Come on, pen. So we're going to factor out a negative GCF. Because we always like what's factored and what's left inside the parentheses. We always want that to be a positive leading coefficient. That's really more of just the way we like to do things in math than anything else. But since it is the way we like to do things in math, we're gonna go with that. So when you see these negative leading coefficients, remember this is negative 1, even though this term here is not negative, I'm still going to want to factor out that negative sign. And in this case, that seems kind of weird because there's actually nothing in common between these. Negative x has no numbers, 8 has no variables, there's nothing in common. But I'm still going to factor out a negative 1. And then I have to ask myself, okay, well, negative 1 times what makes negative x? Well, negative 1 times x makes negative x. And then negative 1 times what makes positive 8? Well, I got to take a negative times a negative to get positive 8. Negative 1 times negative 8 makes positive 8. And then even kind of stranger maybe, usually you won't even see that 1. All you will see in front here is just this negative sign. If it makes more sense to you to leave that 1 in there, go for it. That is fine with me. I get that would be a little bit strange to see just a negative sign out front when you're factoring. But what we're doing is we're factoring out a negative 1. Okay. Next one over here. Same kind of thing going on, but a little bit more. Look at the numbers. You've got negative 1 and 10. I want to factor out that negative 1, even though there's nothing in common between the 1 and the 10. So I'm going to factor out a negative 1. Then I can look at my variables, x squared and x. Well, there's an x in common between those. What do I have to multiply by? Negative 1x times what makes negative x squared? I've got the negative sign already. I've got one of my x's, but I need x squared, so I need to multiply by another x. Negative times a positive makes the negative. When I multiply on this one, I need to get a positive, so a negative times a negative would make a positive. 1 times what makes 10? Well, 10, and then I've already got the x. So I've got negative 1x. Oops, I've already got the x. I said it, and then I wrote it down anyway. There we go. That makes more sense. So the negative 1x times negative 10 turns into positive 10x. Down here, get some erasing going here. Down here, we've got these 3, 3, and 3 again. I'm going to factor out a 3 because it's common to all of them, but since that negative is in the leading coefficient, I'm actually going to factor out a negative 3. And I look at my exponents, I see x to the third, x squared, x. There's at least one x in all of them, so I'm going to factor out that 1x that's in all of them. What do I multiply by? Well, negative 3 is already there, and I need to take x times x squared to get x to the third. On this one, well, the negative 3 is already there. X times x makes x squared, plus sign in the middle. Now in this one, I need to get positive 3x. Well, I've got negative 3x. I need to multiply by a negative number. Negative 3 times negative 1 makes 3, and we've already got the x, so no more x's in there. And then the very last one here, same deal. Well, we've got negative 1 and positive 1, so I'm still going to factor out a negative 1 because I don't want that negative. I want that negative leading coefficient factored out. And then in my variables, I've got x squared and x to the first. Well, I'm going to factor out that x to the first power. So negative x times what makes negative x squared? Well, I got to take x times x to get x squared. And that negative sign makes it negative. Negative 1x times what makes a positive x? I need that negative 1. Negative 1 times negative 1 makes positive 1, and I've already got the x. So there we go. So down below here, here's what we want you to do. And I'm going to have you pause the video and try these, and then maybe have like the sub put this back up. Either show it to you if you think you got them to check them, or put it back up in the last 5 or so minutes of class so that you can take a look at them. The first step they want you to do is to write them in order of exponents, highest to lowest. So you can see here, this is 2x plus x squared. That's backwards. I want to write that as x squared plus 2x. We always want it written in that form. So do that first, then factor it. Find the GCF. Ask yourself that question. What do I multiply to get x squared? What do I multiply to get 2x? So pause the video now. Come back when you're done or with 5 minutes left to check on your answers. Okay, I'm going to go real quick here. So on this one, the greatest common factor is just x. And I'd have left over x plus 2. On this one, I'd rewrite it as 4x plus 2. My greatest common factor is just 2. And so here I'd have 2x and 1. 2 times 1 is 2. I usually think of that as I factored everything out of the 2 and only 1 is left over. Okay, here I'd have 15x squared plus 5x plus 10. So I just moved that one to the front because it's the biggest. My greatest common factor here is just 5. And I'd have 3x squared plus x plus 2. Next one here, I'm going to rewrite them. Negative 9x squared, because that negative goes with the 9x squared, plus 3x. This 3x is positive. It's not written there, but it is. My greatest common factor here, I'm going to use a negative 3. I want to pull out a negative sign because that negative is the leading coefficient. And then between 9 and 3, 3 is the common factor. X squared and x, I'm going to factor out an x. On this one, negative 3 times 3 makes negative 9. And x times x makes x squared. Negative 3 times negative 1 makes positive 3. I've already got the x, so I don't need any x's. On this one, negative 6x squared minus 2x plus 4. I'm going to factor out a negative because I have negative leading coefficient. 2. This term doesn't have an x, so I can't factor out an x. So here I would have 3, because negative 2 times 3 is negative 6. X squared. I don't have any x's, but I need the x squared. Negative 2, times negative 2, that's just 1. And I need the x because I don't have an x here. So plus x, 1x, but I'm not going to write it. And then negative 2 times what makes 4? Well, negative 2 times negative 2 makes 4. The last one here, negative x squared plus x plus 10. If I look through there, the only thing that's in common is actually really 1. But I'm going to factor out a negative 1 to get rid of that leading coefficient. And now let's have x squared. So negative 1 times x squared is negative x squared. Negative 1 times negative x, because a negative times a negative makes a positive. And negative 1 times a negative 10 is a negative times a negative makes a positive. Really didn't factor all that much out there. All I was doing was just trying to get that leading coefficient, so it wasn't a negative number anymore. So there you go. If you've got some time left, flip the page over and you've got the proficiency practice to start. That's what you're going to have time to work on tomorrow. And then on Friday, we'll take that class time to kind of work through whatever it is we need to work through, understanding that, I've been gone some time here and we're going to have some questions, and that's okay. So hopefully I'll see you on Friday.